Hello everyone. This video is about the demonstration of our project. Our project is an exam portal which simulates some of the concepts of distributed system. Now let's open these tabs. So here we have teachers dashboard, then a students dashboard, then processors log. Then this tab is about the clock synchronization simulation, then a backup server's log, and a replicated database. So first, let's start with an exam. Here, as we can see, the exam has started and the live submission status is visible here. Now on the student portal, we can manually look entry of an student. And it's submitted. You have submitted successfully. Now let's make an entry for another student, which is roll number 5. I'm just selecting random answers. Submit. Yes, it is submission is done. Now in the teachers portal, we can see the right mark sheet and the live exam submission. As we have done submission for roll number 3 and 5 manually, so it is visible here. And also, it, we can also see the status of the students. Like some of the students have submitted their exam, some have got terminated. The termination is due to the students getting caught while cheating. We can look at that here. As we can see, if the student is caught cheating uh, two, uh, two times, then his exam gets terminated. Now, if we see the processor's log, here we can see the exam status is 100, and here are the submission statuses. Uh, these many numbers have got auto submitted, which means the timer ended and their exam got over, or else they got caught cheating and hence their exam got auto submitted. And these s- students with having status as submitted, which indicates they have submitted it manually. Now let's move on to the next part of the project, which is clock synchronization. Here we have tried to simulate the Berkeley algorithm and the Ricart-Agrawala algorithm, which are for mutual exclusion. So these are the steps for Berkeley algorithm. So let's start the simulation. Now both the student and teacher clients are connected. We can see the live logs here. So as we can see on the logs, the server will first broadcast its time to everyone. Then students will calculate their clock value. Then the average clock value will be calculated. And then the cap will be decided, which means how much difference is there. And then this will be shared to the broad to the server, and the time will be adjusted for everyone according to the cap values, and the and thus finishing the synchronization. Now let's look at first let's stop this and let's look at the Ricart-Agrawala demo. So it has started. So here the teacher requests the critical section and broadcasts a request like 1P, S1 and S2, which are student 1 and student 2, receive this request and send and OK, since they don't want face. So the teacher receives OKs from all the other nodes. So it enters the critical section. But in the meantime, the student one requests the client section, critical section. But here the teacher is still in the critical section. So the student one's request gets deferred. But after some time, the teacher releases the critical section. And so as the student one's request was in the queue, and the student one receives the OK from the teacher, and then thus enters the critical section. So this was the demonstration of the Ricart-Agrawala algorithm. And coming to the backup server, we can also see that the logs are visible here on the backup server itself. The, the role of the replicated database visualizer is to show the live database chunks. Thanks for watching.